4.3, solving systems of linear equations by the addition method. All right, well, sometimes in the addition method, you can't just do something to one linear equation. Sometimes you have to do it to both. All right, so look at this. If I wanted to get rid of the x's, I can't just do something to this 4 to turn it into a 3, and I can't do anything to this 3 to turn it into a 4. Can't do anything to this 3 to turn it into a 2, and I can't do anything to this 2 to turn it into this 3. So therefore, I'm going to have to do something to both equations. All right, so you first decide, do you want to get rid of your x's or your y's? I like my y's because they have opposite signs already, and we know that one of them has to be the opposite sign. So I like that one, and that's the one I'm going to focus on. So we're going to focus on the 3 and this 2. What number, what is the first multiple that 3 and 2 both have in common? So if I counted by 3's and I counted by 2's, what's the first number I'd come across that they both had in common? 6, right? So I want to turn both of these numbers into a 6. So I'm going to bring down both my equations. I'm going to bring down my first equation over here. What's it? Plus 3y equals 14. And then I'm going to bring my other equation down here as well, because I got to do something to both of these guys to turn them into 6's. Now remember, we can't just get rid of, we can't just multiply the y by something. We have to multiply the whole equation by something in order to keep it the same equation. So whatever I do to one number, I have to do to all of them. So my goal, again, is making these y's into 6's, right? That's my goal. So how do I turn this 3 into a 6? I multiply it by 2, right? So I can't just multiply the y by 2. I have to multiply the whole equation by 2. Don't forget this last term. That's always what I would always forget that when I took this class. So 2 times 4x is 8x. 2 times 3y is positive 6y. And then 2 times 14 is 28. All right, so again, over here, we got to do it to the whole equation. We can't just do it to the y. I want to turn this 2 into a 6. So what do I have to multiply 2 by to make it a 6? 3, right? But again, I have to do it to all of them. I can't just do it to the y. So 3 times 3x is 9x. 3 times negative 2y is negative 6y. And 3 times 2 is 6. All right, now that we have two variables that are opposite of one another, we're going to just bring one of our variables over. I'm just going to bring this one over here and stack it. Make sure my variables and my numbers all line up. Equals 6. And then the addition method says we're going to add. Well, hopefully my y's cancel because that's why I did what I did. All right, so they canceled. They were complete opposites of each other, so they canceled. 9x plus 8x is 17x equals 28 plus 6 is 34. All right, so then we solve algebraically for x. Divide by 17, divide by 17. X equals 2. So now we know what our x is. Our x is 2, but we still need to find our y. So you can choose any of these equations. You can choose one of the first two or even one of the two that we changed. I'm just going to bring down my first equation. So I have 4x plus 3y equals 14. But in place of x, I know what x is. X is 2. I found it right here. So in place of x, I'm going to plug in a 2. 4 times 2 plus 3y equals 14. So we get 8 plus 3y equals 14. Now we just have to solve it algebraically. All right, we got to get the y by itself, so we're going to subtract 8 to both sides. Can't do it to one side, not the other. 3y equals 14 minus 8. What is that, 6? 6. Then continue to solve algebraically. The 3 and the y are multiplying, so we're going to divide by 3, but if I do it to that side, I have to do it to this side. Y equals 2. So my point is 2, 2. This is where they're both going to meet, where these two lines are going to meet, is at 2, 2.